Hello, it's Duncan. This week we return to the Checkout Kata, but in a change to our advertised program, I'm parking parsing pricing with LLMs. That's because our customer has asked us to start work on meal deals. A sandwich, a snack and a drink? What's not to like? Oh, I'm an idiot. That should be if I can't remove them all. Here's our checkout code. The episode where we wrote it is part of a playlist that will be in the show notes. The checkout works by scanning a code, adding those codes to a list of strings, and then using the price rules to work out the total price. And basically we ask each price rule, which is a function that takes the list of strings and returns an int, how much it wants to add to the total, and then we add all those up to give our display of the total price. And these discounted price rules, here it is, represent a sort of multi-buy. They're normally 50, but we get a discount of 20 if we buy 3. And that was the original spec of the Checkout Kata. What's happened now is that our customer has come to us and she says she wants to be able to offer things like meal deals. And the simplest sort of meal deal would be if you buy 1A, 1B and 1C, then you get a particular discount. But maybe an A, a B and a D wouldn't give you that discount. So think a sandwich, a snack and a drink. That's a completely different pricing structure to our discounted price rules, but it will be interesting to see whether our price rule and our checkout can stay the same. I think maybe what we'll do is we will rename this checkout test to be discounted price rule checkout tests, because this tests the checkout. It's down here with only discounted price rules. So having renamed that, I think what I'm going to do is I'm going to take this thing and I'm just going to copy it to give us a test which is MealDeal checkout tests. We'll add that to Git, and it's got the wrong name, so we will rename it. And let's just run all the tests. So we're starting on a firm foundation. Okay then, our meal deal checkout tests. I think the test for no items would be a good start, but let's just get rid of all these other tests. For now, I think I'll empty this one like that. And now for the meal deal, we probably still need to know how much our products, the A, B, C's and D's, cost when they're not in the meal deal. So I think we're going to leave these discounted price rules in here, and we're going to add a meal deal. That doesn't exist yet, and let's think how we'd represent a meal deal. I think the answer is that if it has the right products in it, we give you a fixed price. So I might say products equals, and this feels like a set of the product codes. So we say, okay, an A, a B and a C make up a meal deal, and the price of that meal deal equals something. How much would that be? Well, an A is normally 50, B 30, C 20, so that's 100. So let's say we'll give you all 3 for 80. Having done that, then we can go to the error and ask IntelliJ to create us a class for meal deal. And I think we just put it in here, maybe down the bottom. And you can see because we gave the parameters names, it can default to those. So we'll say good. And now we have a failure to compile up the top. And that's because this has ended up as list of any, because meal deal is not a price rule. Just see whether it will fix that. None of those things are what I want, because what I really want is for meal deal to implement price rule. And if I do that, the error at the top goes away, but we end up with one down here, which is that we need to implement the members of PriceRule, which is our invoke. And that allows us to compile, even if it doesn't know what P1 is. I think actually you can put that in here. So we could say this is products. Oh, crash the IDE. What happened there? Never mind, report and clear all. It is the EAP, so we can name that in there. And had we have done that, I'm reasonably confident that would have known this is products. Although, in fact, looking over here, we've called those codes. So let's try and rename that to codes, and lo and behold, it doesn't rename it here. Don't know where that set of string came from. Never mind. Okay then, now we've got the thing compiling, let's think about a test. So this is the meal deal test. We've got a test for no items, and let's have a test for the meal deal. How would this look? Well, let's build it up. We know that no items is price of 0. We can say if we just get an A, then we know that should be 50. I'll run the test just to check. And oh dear, of course we had the not implemented in there. So instead of not implemented, I think I'll just return 0 from here for now. Check that's still good. Okay, that's better. Right, 1A is 50. Scroll back up so we can see. If I add a B into that, then that should be 50 plus 30 is 80. And then if I add in a C, well, I want it to be 80, but I think it will be 100. So let's just check my thinking. That's good. And now I want to pass that test, which is now failing. And it's failing because we expected at 80, we got 100. And we could make it work, I think, just by returning the discount that we want for the meal deal from here. So we could say minus 20. Is that right? Oh no. And that's because the meal deal is now returning minus 20 even for the case where we've only put in 1A. Well, that's no good. It's going to be a bit hard to fake it till I make it. So let's see how we could make the meal deal work. We've got a set of products and we've got the codes. What I think we want to do is remove the batches for the meal deal from the set of codes. In fact, a simpler way of looking at it for just one meal deal is if the codes contains all the products. But wait, we can't see the products because that isn't a field. Maybe Alt-Enter will fix that. Create a property as a constructor parameter. Well, that's a bit brain dead, isn't it? We already had one. So let's go and do it by hand. We'll say this is val products. I'll make this val price just in case it comes in handy. So if the codes contains all the products, then we have a meal deal and we can return the discount, which isn't the same as the price, which is a bit awkward. Else we can return no discount. Does that do it? Oh, good. Tiny little refactor. We'll just pull that out of the if. Good. And now we've got two problems outstanding. One is what to do about two meal deals, and one is how to work out what the discount is from the price. I think the second one I'm going to punt for a moment. I'm just going to call this the discount. So let's rename that to be discount. Then we can return minus the discount from here. And when we create a meal deal, we did that up here, we can say this is now the discount. So it's not the price of 80, that's a discount of 20. Which when we build this, we could work out from these price rules here. I'll come back to that. But does it work? It does. So now let's scan some more products. And I think we'll scan them backwards. So we'll say, now I scan a B. That's 80 plus 30 is 110. Oh, that's surprising to me. Actual 95. What did I mess up? A 50, B 30, C 20. So that's 80, and I put in a B, and a B is 30. But now my discounted price rule for B has kicked in. So I think what I have to say is, at the moment at least, we are not going to have any discount on the items in the meal deal. Is that better? Phew. Okay, so now we'll put back in a C. That will add 20, so that'll give us 130. And we'll put in another A to give us two meal deals. And if one meal deal was 80, then we expect 160 there. And actually we don't see the discount. And we don't see the discount because we only know the code contains all the products, not that it contains it twice. I suppose the question we really want to answer is, how many times can I remove all the products from all the codes? That will give me the number of meal deals. This isn't going to be very functional, but I think if I was to say, let's give ourselves a val remaining codes is the codes to immutable list, and now set up a var for the number of deals, which is 0 to start with. Now I might loop, and I always find it easier to loop forever to start with at least. Do you find the AI completion gets in the way a bit here? Not sure it's suggesting the right thing. I'm just going to switch it off. Goodness me, there are a lot of those. Let's just switch them both off for now and see how we do. All right, so back here, I think I'm going to say, let's go to our remaining codes and remove all products, the ones in the multi-buy. Now, remove all returns a Boolean that tells you whether or not they were removed. So I think we can say that if we tried to do that and it was false, then we don't have a multi-buy and we can break. Otherwise, we do have a multi-buy, we have removed them, and we can say number of deals plus plus. And now we can get rid of that and just say return number of deals times minus the discount. That sort of makes sense to me. Let's see. Test meal deal fails at, it fails straight away. It failed, yes, on the first meal deal. Oh, I'm an idiot. That should be if I can't remove them all. Run again. Oh, and now it turns out I failed earlier. That's unexpected. It looks like I've taken a discount just on an A. That's a bit weird. Well, that took a bit of thinking about. It turns out that remaining codes remove all. Doesn't actually tell you what it does. Have to go here. And remove all returns true if any of the specified elements was removed. Which is to say, if the collection was modified at all. So if we go back here, then when we've got just the A, that's in this set, we removed it. So this was true, so we added 1 to the number of deals. That's just annoying, isn't it? So instead, I think we're going to have to say, if remaining codes contains all products, well, in fact, if it doesn't contain all the products, then we can break. Otherwise, we will remove them all and add to the number of deals. Ta-da! Oh, still not right, but at least we've got as far as the second meal deal. Okay, I think I've worked this one out. Remove all here is going to remove this ABC, but it's also going to remove this BCA. It removes all the instances of the things in the product set from the things in the code set. So it's treating this codes like a set, but really I want to treat it like a bag. I'm sure we're getting inefficient now, but what I think I'm going to do is I'm going to set in a little loop. I'm going to say products for each, and this is the code. And now for each code, I'm going to say remaining codes dot remove first. And I want to say remove first where? Remove first or null, remove last, remove at, remove all. Well, the fact that we have remove all and remove if suggests that maybe remove if will do it. Let's have a look. This says removes all the element that satisfies the given predicate. No, not what I want. You know what? I'm tired and I'm not getting a lot of pleasure out of this. So I think I'm going to take this out. I'm going to take this out. I'm going to make this into a val. And I'm going to say, hey, Junie, you have at it. I think we could say make test meal deal pass. And see how it gets on. Okay then, well, that had actually got the test passing very quickly and then sort of, I don't know what, carried on talking to itself, I think. Let's see what we got. So it says, if the product is empty, return 0. The counts per product is how many of those each we had. And the number of complete deals is the minimum count across all required products. I suppose so. And then we apply the discount per complete set. Just going to check it wasn't lying about passing the tests. That's good. I'm always suspicious of early returns like this. I feel if the algorithm is good enough, then it should be able to do without it. So let's just check. That is still happy. Oh, I say that, but we only appear to be running the parsing tests. I guess that's because that's what Junie did. Let's run all of them just in case. Phew. I'm not sure how efficient this is. For each one of the products in our set of MealDeal products, we have to go and count how many codes there are of that code in the scanned codes. That's 2 loops. And another loop here over the values in order to find the min or null. But I think it's quite understandable. Don't suppose we need that. And maybe the rest of the comments are quite useful. At least this solution hasn't got my horrible mutable list. So we've now got this outstanding issue here of the fact that we are specifying a discount rather than the price of a meal deal. Thinking about it though, we have another problem, and that's that proper meal deals don't just require that you buy a particular sandwich and a particular snack and a particular drink. You select the sandwich from a set of sandwiches and the drink from a set of drinks and the snack from a set of snacks. So in fact this product should be a list of set of strings. Given that, we'd have to price every one of the things in the meal deal using this discounted price rule, I suppose, in order to know what the discount actually is. And we also have to decide whether we can have a discounted price rule for something in a multi-buy. In other words, if I get a discount for buying 2 sandwiches and I get a discount for buying 2 drinks and I get a discount for buying 2 snacks, do the multi-buy discounts apply as well as the meal deal discounts? That decision, I think, is beyond my pay grade. So this is a good time, I think, to pause the work on this, go back to our customer and find out what she thinks the relationship between different price rules should be. If you want to find out the answer as well and see what effect that has on our code, then this would be a good time to subscribe to the channel. Like this video so that YouTube shows you more of my stuff. And maybe even buy the book that I wrote in that price called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.